All right, let's dive into what is basically a real-life scientific detective story. It's unfolding right now at the Campi Flegrei supervolcano, which is just outside Naples, Italy. Now, this volcano has been restless for years, but lately, the activity has been accelerating in some really, really strange ways. And scientists, well, they're racing against the clock to figure out what it all means. So to really get why this is so critical, let's just start with one number, 500,000. That's the number of people who live directly inside the volcano's caldera. I mean, not near it. They are literally living in it. And, if you zoom out from there, the stakes get even higher. The entire greater Naples area, that's over 6 million people in the immediate vicinity. Think about that for a second. This makes Campi Flegrei one of the most dangerous, most densely populated volcanic areas on the entire planet. So yeah, what it does, it really matters. Okay, so to really understand what's going on now, we gotta get to know this volcano's, well, its unique personality. See, this isn't your classic cone-shaped mountain that you picture in your head. Nope, it's a massive sunken crater, a caldera, and it's been restless for a very long time. Its signature move, the thing it's famous for, is something called bradyseism, and you can really just think of it as the ground literally breathing. The whole surface slowly rises and then falls over decades, all pushed by whatever's happening deep underground. And believe it or not, for this area, that constant up and down movement is actually kind of normal. And look, this isn't a new thing. It has happened before. If you look back, there were these huge crises in the early 70s and again in the early 80s. I'm talking the ground swelling up by nearly 2 meters each time, caused a ton of damage, lots of earthquakes. Then things went quiet for a bit, until 2005. That's when the current phase of unrest kicked off. But this time, this time something is very, very different. All right, let's fast forward to what's happening right now, because this is where things get wild. Since around 2021, all the key signs, the ground lifting, the earthquakes, the gas spewing out, they haven't just continued. Oh no, they've kicked into a whole new gear. The volcano is getting louder, and the scientists, they've got the receipts to prove it. So our first piece of evidence, it's the ground itself. Since 2005, the whole center of the caldera has bulged upwards by about 1.2 meters. And this is the really important part, it's not the how much, it's the how fast. After this slow, pretty steady rise for 15 years, the speed of that uplift just took off. It accelerated like crazy starting in 2021. Okay, clue number 2, the shaking. And just look at this chart. It's absolutely staggering. We've seen more earthquakes recorded in just the last few years than in the entire 15-year period before that. It's just, wow. And the key thing here is that the shaking is speeding up right in lockstep with the ground lifting. And then there's our third clue. This one comes from something you can't even see. Gas. Right now, the ground is breathing out over 5,000 tons of CO2 every single day. Now, to put that into perspective for you, that's the kind of level you'd expect to see from a volcano that has like a wide open pipe straight to the surface. It's a huge sign of some really intense activity bubbling away down there. Okay, so this is where we get to the real heart of the mystery. Because it's not just that there are more earthquakes. No, it's that a totally new, really peculiar type of earthquake has shown up. The scientists are calling them burst-like swarms. And this could be the smoking gun everyone's been looking for. So normally, a typical earthquake around here is what they call a volcano-tectonic event, or VT for short. Basically, it's just rock fracturing because it's under a lot of stress. And the main thing you need to know is that on a seismogram, it looks clean. It's a sharp, clear signal, kind of like a single twig snapping. But what they're seeing now, well, the difference is just night and day. A normal swarm, you get distinct, separate quakes. You can count them. But these new burst-like swarms are something else. They're these rapid-fire, chaotic blurs where all the individual earthquakes just kind of blend together into one long, messy, continuous signal. The ground isn't just snapping anymore. It's sputtering. So what in the world could be causing that? Well, the leading theory is that we're watching the rock literally fail because of these super fast changes in fluid pressure. It's not just one single crack happening. It's more like a continuous, non-stop fracturing process being driven by this intense pressure from superheated water and gas. But hang on, because that's not the only weird thing going on. Just as scientists were trying to get their heads around these new earthquakes, another strange signal popped up right next door. And this one, well, it adds a major plot twist to the whole story. This new clue is what they call a geodetic anomaly. Okay, what does that mean? The entire caldera, the whole giant crater, is swelling upwards, right? But one very specific spot, this lava dome called Mount Alebono, it's lagging behind. It's still rising, but it's going up way slower than everything around it. It's just like a patch of dough that, for some reason, isn't rising with the rest of the loaf. And this isn't just a guess. They can measure it down to the centimeter. By May of 2024, the monitoring station right there had risen 11 centimeters less than it should have, based on how everything else around it was moving. That's a huge deficit. It's a crystal clear sign that this one piece of the Earth's crust is doing its own weird thing. And here it is. This is the crucial connection, the big aha moment. These two clues, the weird earthquakes and the slow-moving ground, they aren't separate things. The burst-like quakes are happening in the exact same spot where the ground is lacking behind. They showed up at the same time, and they're evolving in perfect sync. As the number of quakes goes up, that uplift deficit, it gets bigger. They are absolutely two sides of the very same coin. You know, one source I read put this perfectly with a really simple analogy. Think of the rock cap over the volcano as the lid on a pressure cooker. What we might be seeing here is that lid developing more and more and more fractures because of all the strain. And, well, we all know what happens when the lid on a pressure cooker finally gives way. So all of this brings us to the million-dollar question in our whole detective story. What is actually driving all this pressure? Right now, there are two main ideas on the table, two competing theories that are trying to explain all these bizarre clues. Okay, theory number one is the hydrothermal idea. This basically says that the problem is a buildup of super hot pressurized water and gas just below the surface, and that's what's fracturing the rock cap from above. The big risk here? A massive steam-driven explosion. Then you have theory number two, the magma idea. This one argues that the real cause is fresh magma gathering way down deep, like 6 to 8 kilometers down, and that's what's putting the squeeze on the entire system from below. So which one is it? Well, the evidence is tricky. The scientists who wrote the Nature paper, they point out that these burst-like swarms look a lot like signals from other volcanoes that are definitely driven by hydrothermal stuff. But Italy's own volcanic observatory says, hang on a minute, deeper earthquakes and weird changes in the gas could mean magma is building up down there. And of course, the answer could be C, all of the above. It's totally possible that magma rising from below is what's superheating the whole system above it. But honestly, here's the bottom line. It almost doesn't matter if the main driver is hot fluid or fresh magma, because the conclusion is exactly the same either way. The entire volcanic system is under an incredible amount of stress, more than it's seen in decades, and the rock cap that's holding all that pressure in, well, it's getting weaker and more fractured by the day. Look, this investigation is nowhere near over. Scientists are watching every single tremor, every millimeter the ground moves, every little wisp of gas. They're searching for that next big clue. The supervolcano is telling us a story in real time. And the question for all of us is, with the ground shifting and the earth shaking, what clue will they uncover next?